Okay, note 7.1, we're going to be looking at rational functions. A rational function has a fraction, and they're going to have horizontal and vertical asymptotes. We talked about asymptotes before. It's where a line is approaching but never actually reaching. It just gets closer and closer and closer. So it says a rational function is in the form p of x over q of x. That's a fraction. P and q are polynomials, and it says q of x is not the zero polynomial, which means it does not equal 0. Okay, so we don't want our denominator to be 0. In general, the domain of a rational function includes all real numbers except x values which make the denominator 0. Okay, so we're going to be finding the domain of each of the following. So remember, it's all real numbers except what causes your denominator to be 0. So if you look at this denominator, x would be -2, which would make that 0. Okay, so instead of writing out every single x value that we can plug in, since it's all real numbers except that, we're going to write x cannot equal -2, because that would make it undefined. Looking at the next one, x plus 1, x cannot equal -1 on that one, or -2. Example 3, x squared plus 1. If you can't look at it and determine what x would be for that to equal 0, set it equal to 0 and then solve for x. Take the square root. Notice that's imaginary there, because there's not anything squared, and we add 1, that would cause it to be 0. So nothing we plug in would make that fraction undefined. So it would be all real numbers, because nothing would make it undefined. Okay, so it says at the values for which the domain is undefined, there will be one or more vertical asymptotes. List the vertical asymptotes for examples number 1 through number 3 above. So we're going to go back. Whatever causes your denominator to be 0 is your vertical asymptote. So the first one would be, we'll just put VA, x equals -2. Number 2, vertical asymptote would be -1, -2. So it's whatever causes your denominator to be 0. On number 3, nothing caused our denominator to be 0, so there would not be a vertical asymptote on number 3, so you could just write none there. Alright, looking at the next part, the figure below shows the graph of f of x equals 1 over x plus 2. If we look at that function, what causes it to be 0? That would be -2. So your vertical asymptote would be x equals -2. If you look at the graph, look in the middle of these two and draw your vertical asymptote. It's where they're both approaching. So notice it's a vertical line. It crosses the x at -2. So that's where this x equals -2 comes from. So whatever causes your denominator to be 0 is your vertical asymptote. Alright, so you're going to have horizontal asymptotes also. You're going to have at most one horizontal asymptote. What you're going to do is you're going to be checking the degree. The degree of a polynomial is your highest exponent. So you're looking at the highest exponent at the top, the highest exponent at the bottom. If the degree of the numerator is equal to the degree of the denominator, then your horizontal asymptote is y equals a over b. A over b, a is your leading coefficient of the numerator, b is your leading coefficient of the denominator. So you're putting the ratio of those two. If the degree of the numerator is less than degree of the denominator, then the line y equals 0 is your horizontal asymptote, which is the x-axis. If the degree of the numerator is greater than the degree of the denominator, then you do not have a horizontal asymptote. Alright, so we're going to name the vertical and horizontal asymptotes for each function. If none exist, write none. All right, so we're looking at the degree. Remember, we just talked about degree is your highest exponent. Notice on the top, the highest exponent is a 1. On the bottom, it's also a 1. So you're looking at the variable, looking at that highest exponent. You're comparing those. If they are equal, your horizontal asymptote is the ratio, the leading coefficients. Coefficients are the numbers in front of the variable. Leading just means the front. So look, there's a 2 here. That would be a 1. So we're setting up the ratio, 2 over 1, which equals 2. So y equals 2. Vertical asymptote. We are looking at what causes your denominator to be 0. If you look at your denominator, x plus 1, negative 1 would cause that to be 0. So x equals negative 1. That's your vertical asymptote. Your domain is all real numbers except what causes it to be 0. So x cannot equal negative 1. All right, looking at 2. Degree of the numerator, notice your highest exponent is a 2. Same on the bottom, a 2. Those are equal. If they're equal, you're looking at the leading coefficients. So that would be y equals 5 over 2. Just leave it as a fraction if it doesn't reduce. Vertical, notice that the denominator here, we can factor it. Do not find your vertical asymptote until you have factored your denominator. So you can take a 2 out, and you're left with x squared minus 4, which would factor to x plus 2 and x minus 2. So your vertical asymptotes would be at negative 2, because that's what would cause that one to be 0, and positive 2. Domain is all real numbers except negative 2 and positive 2. So those are the two numbers that would cause our denominator to equal 0. All right, number 3. When we're looking at the degree of the numerator, notice there's no variable. If there's no variable, then your degree equals 0. So degree of the numerator is 0, degree of the denominator, that highest exponent is a 2. You're always comparing the numerator degree to the denominator. 0 is less than 2. If the degree of the numerator is smaller on top than it is on bottom, it's y equals 0 for your horizontal. And make sure that you're writing y equals and x equals on these, or I'll count off. Vertical asymptote, we already talked about it. X squared plus 1, there's not anything squared. And we add 1, that would give us 0. So there would not be a vertical asymptote. Domain is all real numbers because nothing causes your denominator to be 0 there. Looking at 4, degree of the top is a 1, degree of the bottom is a 2. 1 is less than 2. So anytime the top is smaller than the bottom, then your horizontal is y equals 0. Vertical, look at your denominator. We can factor it to x plus 3, x minus 3. And so therefore our vertical asymptotes would be negative 3 and positive 3. So if you want, you can write it as that. So therefore our domain is all real except those two values, negative 3 and positive 3. Degree of the numerator is 2. Degree of the denominator is 1. Compare the numerator degree to the denominator. 2 is greater than 1. When they're greater, then there's not a horizontal asymptote. Vertical asymptote. So looking at the denominator, negative 2 would cause that to be 0, so x would equal negative 2. Therefore, domain is everything except negative 2. So x cannot equal negative 2. Degree of the numerator, it's your highest exponent, which is 3. Degree of the denominator is 1. 3 is greater than 1. If it's greater on top, there's not a horizontal asymptote. Vertical, 3x plus 1. Some would say none, but there is something that would cause that to be 0. Set it equal to 0 and solve. So x would equal negative 1/3. Domain, x cannot equal negative 1/3. So sometimes you can have a fraction. Alright, this is just a summary. The graph of a function has vertical asymptotes at the zeros of the function, which means your denominator is 0. If the degree of the numerator is blank to the degree of the denominator, your horizontal is y equals the ratio of the leading coefficients. That's when they're equal. If the degree of the numerator is blank to the degree of the denominator, your horizontal asymptote is y equals 0. That's when the numerator is less than the denominator degree. And then the last part, if the degree of the numerator is greater than the degree of the denominator, then it does not have a horizontal asymptote. Okay, so this is just the basic of a rational function. We will get into graphing, and we have to know those vertical and horizontal asymptotes before we can graph.